Okay, we're live.
Okay, first question is true. Second is true, right?
It's on you.
Oh yeah, I don't have the quiz pulled up yet. Sorry, hang on.
Sorry, I wasn't ready.
Did anyone have any specific questions?
No, again, just like work through it like we have done.
Yeah, this time.
You're blocking the screen.
6.
I'm just really missing my second monitor right now. We're in the middle of moving. It's already over at the new place, but we don't have Wi-Fi there yet.
Oh, that sucks.
Easy. Ow! Hey now. Sorry, got nailed in the face with a pepper.
I understand.
Yeah, my kid's just getting to the grabbing stage where he starts grabbing everything.
I can go ahead and read question 3.
Okay.
So, use the normal probability applet to find the combined area under the standard normal curve. That is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. For example, yeah, blah, 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 blah.
Okay, so put the number 1.358 in the normal, applet. And then
applet go.
The under the information, we can click normal probability applet. And I think we can use this. I'm sorry. I always make mistakes.
That's why we're all here, right?
So my understanding is that I put the number 0 score 1.358 and I click the middle, the blue part, the shadow. I don't know what to say. And then the number said 0.8255.
I got 0872.
So wait, don't you shade the right side and the left side?
Yeah, far right and far left.
Right and left?
Oh, not
normal curve that is to the right. Oh, and to the left, sorry. I skimmed.
Wait a minute.
Yeah, not the middle, just the right and the left.
My bad.
Okay.
So 175.
175. Okay, got it.
Is that what everybody else got?
Yeah.
Wait a minute. 0.175. 0.175. Yes, I got it. Thank you. Everybody, okay?
Yeah, I can read the next one.
Okay.
It says, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means, nothing's owie, or this cannot be determined.
The last one, I can't be determined.
Pat?
I would want to say it can't be determined.
Why are you so silly?
So the smaller standard deviation. If 9 observations are randomly drawn. 9.
That's annoying.
9 is less than 30. It's a smaller number.
I don't think it can be determined.
That's kind of what I'm thinking.
Same.
So because what? Can you,
Because it would depend on what the observations are. The 9 observations isn't a very large amount, so we can't determine if it's going to be
uh-huh.
regular. So
Oh, so 9 is, you said 9 is small, right?
Yeah.
Okay, okay. Under 30. I got it. Thank you.
So question number 5, which of the following results implies that the spread is X bar decreases as the sample size increases?
Sample size is so. How about the central limit? I can pronounce theorem. Theorem.
Theorem.
Central limit theorem.
Because X bar decrease.
Because law of large numbers is about accuracy, and central limit theorem is your basically
what
X
would that
bar.
mean?
I guess sample
Your
size
standard-
is large.
Well, X bar, that's standard deviation, right?
What?
X bar is standard deviation, right?
Yeah,
Mm-hmm.
I think so.
Your standard deviation decreases. Oh no, so that is accuracy. So that would be law of large numbers, wouldn't it?
Yeah, I think it's law of large numbers.
Because that's the point of the law of large numbers. Is
Last
you
one.
get a bigger sample, you get more accurate. So your standard deviation.
Yeah.
Yeah, let's go with law of large numbers.
Okay.
Yeah, large numbers. Yeah, large numbers.
Oh,
Use
okay.
the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normal distributed with a mean of 150.8 and standard deviation of 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round her answer to 3 decimal places. So with that, we need to do the whole z-score thing, which is the mean minus the measured value minus the mean divided by the standard deviation.
So that'd be 160.
Minus 9.2.
Wait,
That was,
9.2.
yeah.
And then divide that by 8.8.
Oh, sorry. Yeah, I
Wow.
thought you were minusing it by 9.2. I was like, wait, what?
So 1.0456? 1.0454, so 1.04.
It's
6.
1.054.
1.04. Huh?
45. 1.045.
0. Oh, yeah. Yeah, because it's 4. 1.045.
And we rounded to 3 decimals, so 1.045.
1.045. Okay.
Sleepy? Yeah. Yeah, sleepy. So then that's the
What's one we
z-score.
had to
So
do it by the square root?
huh?
What's the one we
So-
had to divide by the square root?
So this time we don't need to use that formula.
That's what I'm
Because-
wondering. Which formula is that? I don't remember.
That's the sample means, the distribution of
Okay.
sample means.
That's what it is.
Baby. Okay. So you got it?
Yeah.
Mess,
1.0.
mess.
So what is the probability that
Go ahead. Sorry.
what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So for this, we need to then put in our z-score into the applet.
So Above, that means is right side, right? No?
Yeah.
Right side. So
For
put
above
the
160.
number. Okay, hold on. 1.045.
That'd be
Then
0.148.
0, yeah,
Yeah.
same.
Do we do the middle and the
It's
right or just the right?
It says
Just
above
right,
160.
because the 1.045 would be corresponding to that score of 160.
Okay.
The right will
Got
be
it.
getting above it.
Okay. Thanks. That
You're
makes sense.
0.148. 0.148.
Okay, so a random 5 of the students were selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these scores? So this is where we use that square root, I think, maybe.
So the sample means we need the mean of all these.
Just add everything and divide 5.
Not your calculator.
No,
right.
no. Is that right?
That would be how we get the mean of it.
Mm-hmm.
It's not your calculator. So I got 160 as the mean.
Mm-hmm.
160?
As the mean.
So if that's
Oh.
the mean, then
Same.
it's 160.
So that means it'd be the same z-score, wouldn't it?
Yeah.
Yeah.
I'm sorry. I'm lost. So you said you added everything in the divider 5?
Yeah.
No. Oh, okay. Oh, you already calculated?
Because she got a 160, which is the sample mean. So it would be the exact same z-score.
Yeah, it would be the same. So it'd be the
1.045.
1.045.
Right.
1.045. I'm so sorry. I'm so sorry. Again, you said 160 plus 175 plus.
Yeah, the sample mean is 160, so that's the mean of those 5 scores. And then that 160 is the same score that in the previous question, so you'd use the same formula.
Previous.
So you come out with the same z-score because it's 160, and our answer was 160 for the mean. So you'd end up with the 1.045.
Oh, okay. So I said, hold on. I'm so sorry. So question 6, right? You were talking about question 6?
Mm-hmm. It's the same as question
Right.
6.
Same answer for question 6.
Just because our mean is the same as hers, so the score ends up being the same.
The score is the same. Select the grades. They are. I think I can understand. Okay, let's move.
Okay, this next one looks like it might be a bit more to it.
What is the probability of 5 randomly? The many activities stood in the previous problem. What is the probability?
So how do you go about figuring this one out?
I was trying to find the textbook again and take a brief look through there. Because this one,
The score. What is
because it's not quite the same like we did with the other one, where it's just simply the area there. Because I think this one does require a bit more of a formula.
What is the probability of 5 randomly selected? How to calculate? What is the 5 randomly? That means n equal 5? No.
I mean, I don't know, because you could literally pick any numbers.
What means
Probabilities involving the mean.
greater than the mean. Greater. Okay.
I think it is just the same. I'm looking back in the online textbook, the third section. Says if the sample mean is normally distributed, then we can consider the sample mean as one observation from a normal distribution. So with the mean and standard deviation of with this in mind, we can compute the z-score for any value of this random variable. Okay, but I think this might be the one that you're talking about that had the square root, because it's the value minus the mean over the normal standard deviation divided by the square root of n, the number of values.
So would we just use those same 5 scores to figure this out?
No, because I think it's in order to get the value, because we're aiming for, let me get back to the quiz. So we want to try and find one that has a higher mean than 160. So I think that would be our value. And then we need, as for inputting that, so it'd be 160 minus the mean. And then, but instead of the just regular standard deviation that we were putting in earlier, was like what, the 8.8 or something, we would need to put that divided by the square root of n. Based on what this formula is looking like.
5 randomly select a student. We have means.
Does that make sense, or am I just off? And
yeah, I'm just not sure where we get the first numbers from. So we just use 160 again.
Right. So it would be 160 because we're trying to find the probability of getting higher than that score, since it was saying we're looking for that 5 randomly selected students will have a mean score greater than that mean. That we're trying to see what is high. If we've had to pick 5 random ones, will it be greater than 160? So when you find where the 160 is it anything more than that?
So if we do 160 minus the 150.8 divided by the square root of 8.8, comes out to 3.1013.
Well, it wouldn't be the square root of 8.8. It's 8.8. Let's see where that. Okay. It's the 8.8 divided by, it'd be the square root of 5.
Oh, 5 because that's how many samples we took?
Because that's how many samples we have.
Daniel.
So because you have 160 minus the 150.8, which is the 9.2. Then do you divide that by the 8.8? So where does the 5 fit in there? That's where do you fit that in the equation?
So the equation is
randomly
minus the mean, and then all of that is over the standard deviation divided by, so like this is almost in parentheses.
Oh, so the deviation divided by the square root of the sample.
Square root of n.
Square root of n, and then so it'd be the 9.2 divided by that answer.
Wait a minute.
Right. Let me see. There. We can use the normal.
Zero. 3.995.
So I got 5.4583.
I'm sorry. What is x minus mute? So 160 minus 150.8. What? Okay. Okay. 150 minus 150 9.2. Okay.
What are you doing?
So
Wait, Jordan, what did you say you got?
So I got 5.458.
As the
hold
Z
on.
score?
No, see, so I did 160 minus the 150.8, which gave me 9.2.
Right.
Mm-hmm.
And then I did the 5 divided
Root
by the
5.
8 point.
Root
5
5.
What?
Root 5.
Root 5.
The square root of 5?
Yeah.
Oh, I did
I'm
5 divided by square root of 8 or 8.
Yeah, it'd be reverse that. So it'd be 8.8 divided by the square root of 5.
5. Okay.
Yeah.
Because that number wasn't looking right or making sense.
Yeah, I got a 2.3377.
Hold on. What some point 2.
Amy, what did you do with my pen?
2.3376. You said? Did you?
77 is what I got. 2.3377.
Okay, because you did 9. Okay, 2.3377. Okay.
So 2.3377.
Okay.
That's what I got.
Uh-huh.
Yeah, I got the same.
So that would be our
So
Z score.
4 decimals.
so
That's
yeah,
the Z score.
I'm here.
2.3377 is the answer, right?
Well,
2.
no, that's just the
No.
Z score.
Oh.
Now we need to put that into the applet.
Oh, okay.
And then we're
So
looking
that means
for
less than or more than? Greater
More than. So just the right.
Okay.
that's
And
a
then put
We also need to round
0.0097.
that to
4 decimal
2.3377.
places.
So 0.0000
I got 0.0097
That's
Yeah.
what I got.
Me
because
too.
it has to be 4 decimal places.
Yes, that's right.
can't help
0.097.
Do you want the pepper?
round your answer to 4 decimal places.
0.0097. Got it.
I just keep also thinking in terms of like chemistry, like significant figures instead of just round to this decimal place.
Yeah.
Would it be more than that? But I don't know.
Okay. We need to wrap this up. I gotta go here real quick.
Okay, we only have a few more questions left. About 5 more questions.
Okay, so participate test.
What is the shape of the sampling distribution of the random variable x, which represents the left sample mean of the 81 students who were selected?
So far we know that the mean is 3.5 and deviation is 0.7 and the sample n equal 81, right? And this one is left skewed. I can't pronounce. So far we know
It's
that,
a
right?
pretty large sample, so would that one be approximately normal?
I think so.
Let's
Because
go
it is
with
a
that.
larger
Because
sample.
sample number is large, so the shape is normal.
Yeah, I
talking
think
about it?
normal.
Okay. Okay, question is normal. Okay. What is the mean? Question 11. What is the mean of distributed sample means? Means 3.5? So means 3 for possible sample size. Or possible samples.
Would it be 3.5?
I think so.
Yeah, I think so too.
You said 3.5?
Yeah.
Yeah,
Let's go with that.
agree.
Yeah, especially since they're saying just round the answer to 1 decimal place.
Yeah.
Okay, 3.5. And now question 12. Okay. So root 81 divided.
So what is the standard deviation of the distribution of the sample means of all possible samples of size 81 that can be drawn from the parent population?
So my understanding is that n equal 81. So put the number in the n. I don't know what to say. Root 81 divides 0.7. That means 0.7 divides 9. What was it?
Deviation of the distribution.
Because the formula under side is standard deviation.
Why would we be using that formula though? Because that we're not trying to find the z-score.
Okay, let me.
We're trying to find the standard deviation. So we would need to work
Deviation
backwards.
that is sorry, my light. You can see? No, you cannot. Like this.
So in the textbook
You
it
know?
says the standard deviation of a random variable x is standard deviation over the square root of n.
Oh, it is?
Yeah.
Oh,
Deviation of the random.
So it would be what she was saying. It would be 0.7 over the square root of 81.
So 9. So
yes.
0.7 divided by 9?
Yes.
And I got 0.0778.
Yeah. So 0.0.
0.778.
778 because of
Wait.
4
0.778 or 0.077?
0.078.
0, yeah. I was like, wait a minute, I did that wrong.
3 decimal, around the 3 decimal.
Right.
Okay, 0.078. Okay.
So what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? Round your answer to 3 decimal places. So for this, we're going to need to find the z-score of 3.3.
3.3 minus 3.5. That means minus 0.2. And we can use 0.00. No, 0.078.
Yeah, so we divided by that.
Okay. That's a new word. So minus 2.564.
Right, that's what I'm showing.
Yeah, I got it. You guys got a negative, right?
Yeah.
Negative, yes.
So then you put that in the applet, right?
Wait a minute.
Yeah, it's negative because we're pulling to the left side because it's below the mean.
Yeah, less than means left side.
Come here. Come here.
Minus.
Come here.
2.564, right?
Point.
So mine's 0.005.
0.005.
No?
I got 0.103.
Really?
Oh, sorry, never mind.
Okay, hold on.
I didn't realize the right button. Yeah, you're right. 0.005.
Because I put the number 2.564. Hi, baby.
Yeah, so 0.005. That's what I'm showing.
Yeah, I got that. Yeah, I had the wrong one
Okay.
selected.
Oh. I know, but
The probability that the mean GPA for the 81 randomly selected students will be greater than 3.3. So that would be everything else.
Yeah.
So that'd be the 0.9948.
That's
So subtract the 3, so 995.
Oh, hold on. So that means the middle and
Middle and
left.
the top, because it's everything to the right of the bottom line.
So you said 0.995?
That's what I'm showing.
Okay. 0.995.
Okay.
One more.
United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than was observed in this sample. Record your answer to 3 decimal places. So if the answer is that, blah, blah. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones observed, but also values that are as far away from the mean as ours in the positive direction. So it needs to be both the low and the high.
Okay, so far we know that the mean is 177.6, and the standard deviation is 26.7. Is that correct? Am I correct?
Yeah.
So far, and we know the okay. Okay.
So that's the sample mean. So the standard mean is 185, right?
Where the number come from?
Well, yeah, the sample mean is the 177.6.
Okay, never mind. Just kidding.
177.6. And then standard deviation is 26.7. Okay, the extreme one is lower than 1. So me in commercial product 85 points. So the sample mean was the weight run. So the 48 is n equal 48.
Right.
Okay, anything else? The sample mean was simple. So 1, 2, 3. Okay, now we have numbers. 1, 2, 3 numbers. That's extreme means that we are not only
So
what's that the answer mean?
So the standard mean is the 185. It's currently the current sample mean is 177.6. So it'd be the 177.6 minus 185.
185.
And then that would be
Okay.
divided by the
48 and
26.7 minus the square root of 48.
so you say 185 minus 177.6. Did you say that?
Right. No, it would be 177.6 minus 185.
So 7.4 and thank you.
I got negative 1.0681.
Not 3.75.
What did you get, Jordan?
1.068.
Really?
Well, I got
Minus?
negative 1.068.
Negative?
Yeah, I just got negative 1.920.
Why it's negative?
Because
So
I'm currently looking at a lower.
so did you say the 185 minus 177.6 or?
I had 177.6 minus 185.
Right.
Oh,
And then did you divide that is by 26.7 divided by the square root of 48?
Yeah. Oh, I didn't do 26 points. I did the answer to that one because that was negative 7.4.
Hold on.
I did that divided by the 26. Oh yeah, sorry. That divided by 26.7.
Oh yeah.
Minus
Sample means the X bar, right? Ah, okay. 177.6 minus 185 equal minus 7.4.
I got negative 1.920.
Yeah, that's what I'm showing as well.
Sorry. I'll do it back in a second.
Okay. So minus 7.4, and the bottom one is 48 root 48 20.7, right?
It's 26.7 divided by the square root of 48.
Okay. So hold on, please. I'm so sorry. So 6.9282. Okay, 26.7 device 6.228. Wow.
So then for this one, we're needing to find probabilities of basically both the far left and far right. So everything except for the middle, right?
Yeah.
Okay. So I'm showing that as 0.0549.
That's what I got.
That's what I got.
Okay.
I'm sorry. So I'm sorry. You said negative 1.920?
Right.
Okay.
So then you put that in a new z-score, and then you get the far left and far right.
Okay.
Okay, so I gotta go. So I just submitted it, and we got question 4 wrong, question 8 wrong, and that's it.
4 and 8.
Yeah.
I'm sorry. You said the last one is 0.055.
Okay, well I gotta go, guys. We'll see you later.
Yeah, see you.
Bye.
0.55. Jordan, we'll go ahead and figure out the answers to those two, and we'll text them to you or something.
Oh, I'm sorry. I want to make sure that the last answer was 0.055.
Correct.
Okay, thank you.
Yeah.
Okay, so what do we do on 4 and 8?
4 and 8.
Which one are we starting with?
So it looks like 4 is the one that we said couldn't be determined.
4.
So that one we
Hold
just
on.
must have
1,
guessed wrong on.
1, 2, 3.
What was number 8?
4. You said 4 and 8.
Yeah, so we got number 4 and number 8 wrong.
Okay.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The
So
distribution of individual observation or the distribution of sample means? Probably sample means.
That would make sense because they'd all be meaned together, and so it'd be closer.
Yeah.
Mm-hmm.
So we'll go with sample means.
Yeah.
Okay, try that
Okay.
one.
Mm-hmm.
Then number 8.
What do you have down for 8?
1.045.
I wonder if well, that's weird because we got the other one right that we put that down for, right?
So I wonder if we were
Or
supposed to do
no?
a different calculation for that.
So
You're
before
fine. We're almost done.
before
Almost
our
done.
answer was 160 was answer?
Right, we said that was the
Okay.
average.
Oh, I think we didn't do the square root on this one.
Oh, because we are looking for.
A sample. So we would need to take the square root of 5 into this one.
So
It's okay. You're okay.
what?
So it'd be
So you would do 160 minus 150.8, which is, I need this. Sorry, I'll give it back, I promise.
Oh.
9.2, and then
divided by the 8.8.
divided
by the square root of 5.
Okay, wait a minute. So G score. Here, Google. 2, 5.
Are we just finding the z-score?
Right, so this would be the z-score. I got.
So in that case, I got 2.338.
Z equal.
Wait
a minute.
Oh, I inputted
X
that wrong.
minus X. Okay. Back to the mute one. Standard deviation is 8.8.
Okay, I need to redo the other way.
And X is 160 minus 150.8.
Yeah.
Okay. And then
Okay, what did you get again, Savannah?
I got 2.338.
Okay, yeah, that's what I'm showing.
Okay.
Really? 160 minus 150.8 equal 9.2, right?
Right,
Yeah.
and then that would
And
be
then divide 8.8.
Divided by the square root of 5.
8.5?
The
Divide.
square root of 5 with that one formula?
Yeah. Not 8.8? No.
And so on this question, we were looking for
The information said mean is 150.8 and the standard deviation is 8.8. So I thought like 9.2 divides 8.8.
we divided by the 8.8 divided by the square root of 5. Because then we need to add in the square root of n. That we're looking for a sample mean.
5. Okay. Oh, okay.
So, and then that is the answer. We're just looking for that z-score. So we just put in the 2.338.
Okay, wait. Hold on,
I'll go ahead and
please.
try and submit it. See if we got those two right.
Okay, now I'm calculating 2.2360 8.8 2.2 wow 3.935 and 2.2 は 3.935
Yeah, go ahead and submit it, okay?
So 2.3396 76. Oh, okay. Whew! 2.3396. Then what to do? Is that answer?
That's it. That's the answer.
Oh, so 3 decimal mean
I'm showing we got those questions right then. I'm showing 100% on the quiz.
Awesome.
so 2.338.
Yes.
Okay. Oh. So if you have one minute, can I make sure the answer? Is that okay?
Yeah.
I'm so sorry. And okay, question 3, 0.175. And question 4 is the middle one. The standard of sample means. And 5 is the law of large numbers.
Correct.
And 6 is 1.045.
Correct.
Question 7, 0.148.
Correct.
8 is 2.338.
Correct.
9 is 0.0097.
Correct.
And 10 is normal.
Correct.
11 is 3.5.
Correct.
12 is 0.078.
Correct.
And 13 is 0.005.
Correct.
14 is 0.995.
Correct.
What's it? 15 is 0.055.
Correct. Submit it.
Thank you. Thank you for your help.
Of course. I feel I'm going to need to actually go back and study this one a little bit more than the previous chapters.
Yeah.
Yeah.
It's all starting.
Okay, I'm gonna go put a really tired baby.
Okay. Okay, well, hope to see you next time.
Do you meet with us on Mondays too?
I want to, but it depends on time. I maybe need to look for another group. I don't know. Anytime I have to look. But I will let you know.
Okay.
Thank you. Bye-bye.